Aboard an aircraft, scientists map the fuels or vegetation burned by wildfire at high resolution.
And so that means that, any object that's greater than a meter, we're going to be able to discern in our maps. And so we can easily identify even down to individual trees.
Fine detail gives them the big picture.
A colorized three-dimensional model of one of the fires that we mapped.
But this image is more than meets the eye.
So this sensor sends out 100,000 laser pulses per second.
Taken with a LiDAR scanner and a very fancy camera called an imaging spectrometer, this view of last year's Miriam fire in Oregon is a mountain of information.
If we zoom really close, these are all the individual observations.
Every single pixel is full of information. This graph shows the data. Only a small portion is in the visual spectrum, but look at the wealth of additional data provided in other wavelengths. This data was collected and processed at the National Ecological Observatory Network, or NEON, based in Boulder, Colorado. Now these researchers know exactly what type of fuel was burned, exactly how much biomass was burned, and what type of emissions went into the air.
Yeah, those emissions are essentially like a soup of chemicals. And those chemicals are going to affect the environment and affect people in different ways. And the composition of that soup really depends on what was burned.
This study will also help show how the fuel type impacts the intensity of the fire and even how it spreads. In Boulder, meteorologist Corey Reppenhagen, 9 News.